Okay. So in 22, they're telling us that 48.6% of the North Dakota population over 18 years old is female. 65.9% of the total population of North Dakota over 18 years old has enrolled in college at some point. So if these two events are independent of each other, what is the probability that a randomly selected adult in North Dakota, so the adult part to me is this over 18 years old, okay? So both percentages they have given us are regarding people over 18 years old. I honestly think that just makes it more confusing. That has nothing to do really with the problem. So let's just assume altogether we're only talking about adults. And 48.6% of them are female. 65.9% of them have enrolled in college at some point. If these two events are independent of each other, what is the probability that a randomly selected adult in North Dakota will be a female who has enrolled in college? So we're looking for someone who is a female and has enrolled in college. So on my notes, number 22, I'm looking for the probability of someone who is female and has enrolled in college. Now, they tell us that these events are independent of each other. And there was, obviously, independence. We have a test for independence. If they give us some data, we can test whether or not things are independent. Here they're telling us that they definitely are independent. Okay? And one of the lesser talked about but features of independent events is that the word "and" in probability means what operation? Who said it? Multiplication. "And" means multiplication. But "and" only means multiplication if the events are independent of each other. But since they told us they are, we can just multiply those two probabilities together. The probability of being female is 0.486. And multiplication, the probability of having enrolled in college is 0.659. And I literally just add those two together, or multiply those two together, 0.486 times 0.659. So my probability of having both happen is 0.320274, which is approximately 32%. So 32% of the population is female and has enrolled in college. Okay? Option 1. Okay, if I jump to 23, what is the 13th term of this sequence? So let's review sequences. Is this arithmetic or geometric? What's happening? What are we doing to get from 3 to 6? Multiplying by 2 or adding 3, right? Then we have to look at what's happening from 6 to 12. Am I also adding 3 there? No, so arithmetic is out. Am I also multiplying by 2? Yes. So this is geometric. So times 2, times 2, times 2. So the R equals 2. And they want the 13th term, so they're looking for A sub 13. Again, we have the geometric sequence formula on our reference sheet. So if I go to my reference sheet, geometric sequence is right there. Copy that down. A sub n equals A sub 1 times R to the n minus 1 power. So we're looking for the 13th term. A sub 13 equals. What's our A sub 1? Let me pop back to the question. What was our A sub 1?
3.
3, very good. What's our R? Times 2 times 2 times 2, so that's a 2. And our N in this case is 13, so 13 minus 1. So it's just plugging this into your calculator. Order of operations first, obviously. Your 2 to the 12th power has to come first. And then multiply that number by 3. And you get 12,288, which is option 3. Good? Okay. 24. Oh, I think I remember not liking 24. The accompanying function models the cost in dollars of a designer necklace X years after it was purchased. If the trend continues and the necklace is sold 100 years after it was first purchased, use the graph to approximate the cost at the time it is sold. So I'm thinking if I extend this, right now my graph is only going out to how many years? 10, 20, 30, 40, 50. And right now, after 50 years, the approximate value is $40-ish, I'm guessing, right? So right now it's approximately $40. And if I were to just kind of guesstimate what's going to happen, obviously after 100 years, it's going to be less than 40, it looks like. But like, how much less than 40? 38, 5, or 12? I can eliminate this one, but that's about it, right? So I think this one is going to, it says to use the graph to estimate. Unfortunately, I don't think this graph is good enough to estimate. Unless we can use the graph, but we have to do more than just look at it, okay? Because there are too many options. So I'm thinking on this one, this should be kind of similar to what we just did on that, whoever asked that question on last night's homework. Cole asked the question. It's an exponential decay model. I think we need to grab 2 points, and the most perfect points I can find are 10 and 100. And I think that's 0, that's above 300. Which is another reason I didn't like this question, because you still have to kind of estimate that. I'm going to say like 330, 325, and hope that one of these is more obvious. So I would say 0, comma, let's go with 325. Okay? And then we're plugging in y equals a times b to the x power. However, I will say one thing about this, and we could have used this technique on the question Cole asked about as well. A is always your what? This is on your flashcard. Your y-intercept. So that immediately is what number? 325. So y equals 325 times b to the x power. And then I don't need to plug in both points and divide. If I already know the y-intercept, I can just plug in 1 point. Don't plug in the y-intercept again, that's not going to do anything for you. Plug in 10, 100. So 100 equals 325 times b to the 10th power. And then I'm going to solve first by doing what to both sides, Margaret? Yep, 100 divided by 325 is a crazy point, 30769230077. Equals b to the 10th. And then what do I do, Jake Clancy? To get this b all by itself.
You have to do the square root of both sides.
No, it's not b squared. If it was b squared, I would take square root. Anthony?
Raise it to 110.
Raise it to 110. So whatever number you have in your calculator, just raise it to the 110 power. and I get B equals, so it's Y equals, my A is 325, and my B is 0.8888155906 to the X power. And now I'm looking for this after 100 years, so I just need to plug in 100 to this equation that I now wrote. So 325 times that crazy number raised to the 100th power, and 3 is a hateful question. I got 0.0024. Did you guys do the same thing? Yeah? I don't like this question. I wonder what I wrote on the answer sheet. I haven't really looked at it since I did that answer sheet last year, to be honest with you. I hate this question because I don't think it works. I liked our 2 points, right? They were good, 10 and 100, and so why wouldn't that work?
You wrote the answer is not there.
Yeah. Oh, I did? Good. You know, it was a terrible question. Thank you, Jake and Sarah. All right, because that's really the technique that you would have to use, given that 3 of those are possible. So, whatever, it helps us review that, but now we also know that this book sometimes isn't perfect. So that's that one. Good. Phew. Glad what I did last year and what I did this year, so I'm still confident in my decision that the answer is not there. All right, so that ends our multiple choice section of test number 2, and we will now jump to 32 and 36, because those are the only other 2 you won't get to on tonight's homework. Such a good question. This has come up a couple times this year, and I got to tell you, we're bad at it. Okay? So, determine all values for K for which the roots of the equation are complex. First of all, what are complex roots? What does that even mean? What are complex numbers? Come on. Oh dear. Complex roots. Imaginary. Okay? Complex is imaginary. So, we need to find the values of K that will make this have imaginary solutions. The key here is the discriminant. And this is on your note cards. Because the discriminant, which is b squared minus 4ac, the discriminant gives us some insight as to what our solutions will look like. Whether we'll have real solutions, 2 of them, imaginary solutions, 2 of them, or just one solution, and it's all as how does b squared minus 4ac relate to 0? Because b squared minus 4ac is underneath the radical in your quadratic formula, yes? So if this ends up being what kind of number will result in complex or imaginary answers? Negative. If b squared minus 4ac is negative, aka less than 0, then we're going to have complex answers. So, if you look at your quadratic, what's b squared? 36 minus 4 times a is 1, and c is obviously k. If this is less than 0, aka negative, we have complex solutions. So that's 36 minus 4k is less than 0, and we have to solve this. Subtract the 36 over, so negative 4k will be less than negative 36. Divide both sides by negative 4. What happens to an inequality sign when you divide by a negative? It flips. So any k that's greater than 9 will result in complex solutions. Any k that's greater, and that's it. And your justification is in your work right there. Okay? So we'll get to 36 tomorrow, and if you need the numbers, obviously, again, it's all online, but night number 2 is right there.